In section 8.2, we're going to be learning the third process in solving quadratic equations, which is completing the square. We already learned how to solve quadratic equations through factoring. We learned how to solve them through the square root method, and now the third process is completing the square. So to complete the square really means to basically figure out what the expression would have to be so that it is a perfect square trinomial. For example, a perfect square trinomial would look something like this, like x plus 2 squared. X plus 2 squared is the same thing as x plus 2 times x plus 2, which in this case would be x squared plus 2x plus 2x, which is 4x, and then 2 times 2 is 4. So the first example is constructing perfect square trinomials. So basically what we're trying to do here is take a trinomial like in part A, x squared minus 14x plus c, and we have to figure out what the value of c is to make it a perfect square trinomial. And it has a couple of easy steps. To find this number, what we do is we look at the coefficient of the middle term. So my middle term here is negative 14. So we take negative 14 and we divide it by 2. It's just something that we have to memorize. We take that answer and then we square it. Negative 7 squared is 49. So basically what c would have to be is 49 for this to be a perfect square trinomial, and here's why. X squared minus 14x plus 49 is what we have here, and this factors into x minus 7 times another x minus 7, which is x minus 7 squared, which is considered a perfect square trinomial. The checkpoint. X squared plus 10x plus what? What would c have to be in order for it to be a perfect square trinomial? We take 10, we then divide it by 2, we get 5. We square that, and 25 is our number. So x squared plus 10x plus 25 would be the trinomial, and that then factors into x plus 5 squared. So the value of c would have to be 25. The answer to A is 49. Now, the whole reason why this is important is because we can use this method to solve quadratic equations. So there's easier types of problems and more difficult types of problems. We'll start with the easy ones, and that's when the leading coefficient equals 1. So first step is we have to make sure that our setup is in, or our quadratic is in standard form, like x squared plus something times x plus something equals 0, and we already have that in part A. Then what we need to do is that little trick. Take the middle term, which is 12, divide it by 2, and then take that, square it, to get what the c value needs to be. So in order for this to be a perfect square trinomial, we need the c value to be 36. But here's the thing. X squared plus 12x plus 36. We can't just like add 36 to this and just be like, oh, okay, let's just add 36. It doesn't work that way. What ends up happening is whatever number you need it to be, you're going to need to configure this equation so that it's still mathematically correct. So what we would have to do is actually add 36 to both sides of the equation x squared plus 12x equals 0, so that we get this. X squared plus 12x plus 36 equals 36. We didn't change the value of the equation, like it's still mathematically accurate. We just added 36 to both sides, which if we subtract the 36 from both sides, we would be back at the original equation. Now what we do is we usually factor it and use the square root method. So when we factor x squared plus 12x plus 36, we're actually not setting it equal to 0. We leave it the way that it is. We factor this into x plus 6 squared equals 36 like this, which is different from factoring, because factoring you want it to always be equal to 0. But what we do here is we like complete the square part of it, and then we factor the left-hand side, usually is where we would need to start. And we do that so that we can square root both sides, because we can solve this using the square root method because it's a quantity squared, x plus 6 squared. We can undo that by squaring both sides. The square root of something squared cancels out, so we're left with x plus 6 equals. Now don't forget, when you take the square root of that plain number, this is going to be positive and negative the square root of 36, which is 6. So we have two answers. X plus 6 equals 6, and x plus 6 equals negative 6. Two ways you can do this. You can either write this out as two separate equations, like I said out loud. X plus 6 equals 6, and x plus 6 equals negative 6. Solve them both out, and you'll get two answers, 0 and negative 12. Or at this point, you can also, x plus 6 equals plus minus 6. You can also solve this for x the way that it is and get x equals positive and negative 6 minus 6. And you have to just do both math problems. Positive 6 minus 6 is 0. And negative 6 minus 6 is negative 12. So you're going to get the same answer either way that you do it, but you have to make sure that one method makes sense to you so that you can arrive at your answers. Okay, the second one. We're going to take the middle number, the number in front of the plain x, negative 6, and we're going to divide that by 2. That gives us negative 3. We take that and square it, and it gives us 9. So what we need to do is turn x squared minus 6x plus 7 equals 0. This 7 needs to turn into a 9. So what we're not going to do is actually add 9 to both sides, because that would not be, you know, a perfect square trinomial. The perfect square trinomial is x squared minus 6x plus 9. So what we need to do actually in this case is not add the number itself to both sides, but add whatever the difference is of what's there and what the number is. So if we need to turn this 7 into a 9, we're basically going to be adding 2 to both sides. Let me erase this. So we're going to be adding 2 to this side and 2 to this side to keep it mathematically accurate. And we would get x squared minus 6x plus 9 then equals 2. Now time to factor the left-hand side. This factors into x minus 3 squared equals 2. Use the square root method. Square root this, square root that. We get x minus 3 equals, careful, positive and negative square root of 2. Now again, it's up to you how you want to go about it. If the second method makes more sense to you, you can just do this. Add 3 to both sides. And you get that our answer would be 3 plus or minus the square root of 2, which means my two answers are 3 plus the square root of 2 and 3 minus the square root of 2. If you would prefer at this step to set this up as two different equations, you can also rewrite this as x minus 3 equals the square root of 2. Solve it, and then x minus 3 equals the negative square root of 2, and solve that, and either way you would be left with these two answers. Now on the next